Let's take a look at number 21. It says identify the graph of the rational function and find the equation of the slant asymptote. First off, let's look at the graph, and then we'll look at how to find a slant asymptote. And I'm going to do this on the calculator first. The key to plugging in a rational function in your calculator, and it's true anywhere in your calculator, anywhere you have more than a single number, or single x, or single I in your numerator or denominator of your fraction, top or the bottom, you have to put parentheses on top and or bottom. So on this problem, we're just going to type in exactly as you see it, putting parentheses around the top and parentheses around the bottom. So I'll press y equals clear to clear out where it's not line. I do a beginning parentheses, and I got negative 2x squared minus 3x plus 2, closing parentheses, divided by, and then beginning parentheses. I'm putting parentheses around the bottom too, x plus 1. Close parentheses, and then graph. Okay, so that's what our graph looks like. We'll come back to that. Let's find a slant asymptote. And let's refresh our memory a little bit on the slant asymptote. Note the degree to have a slant asymptote. The degree of the top must be exactly one larger than the bottom. On this problem, the degree of the top, degree is the largest power of x, so degree of the top is 2, degree of the bottom is 1. So that holds true. If you do have that, then use long division and drop the remainder. So let's find the slant asymptote of this. No way to do this on the calculator. We've got our f of x is equal to negative 2x squared minus 3x plus 2 over x plus 1. Okay, so our slant asymptote. I'll use long division. Now, occasionally you'll be able to use synthetic division, but long division is your sure bet because it'll work no matter what. Now we look at the first term of each, decide what to put up on top. You ask yourself what times x gives you negative 2x squared, and that's negative 2x. Whatever you put up on top, you multiply by what's out in front. So I'll take the negative 2x times x plus 1, and that gives us negative 2x squared minus 2x. Now we're going to subtract that line, which means we're going to flip the signs. So this is going to become positive, and this will become positive. Most of you do that in your head, negative 2x squared minus a negative 2x squared. But I can't show you steps in my head very well, so I do that. Negative 2x squared plus 2x squared drops away. Negative 3x plus 2x gives us negative 1x, or just negative x. And then I'll bring down the plus 2. And we continue the cycle. You look at the first term of each, decide what to put up on top. You ask yourself what times x gives you a negative x, and that's negative 1. Now whatever you put up on top, you multiply by what's out in front. So I'm going to take negative 1 times x plus 1. Negative 1 times x gives us negative x. Negative 1 times 1 is negative 1. We're going to subtract that line, which means we'll flip the signs. So that becomes positive, and that becomes positive. Negative x plus x drops away. 2 plus 1 gives us 3. Now this is our remainder. The degree of x plus 1 is 1. The degree of this is 0. When the degree of this is less, then that's the remainder. And our instructions say to drop that. So our slant asymptote is y is equal to negative 2x minus 1. Well, let's now use that along with our graph to figure out what our answers are. Definitely not A or B. Negative 2x minus 1, so either C or D. Let's go look at our graph and see. And it looks like C. So C is our answer. Let's go check that out. 21C. And that checks. Okay, let's show it by hand. Find the original problem. Okay, if I was doing it by hand, the slant asymptote would be the same. I'm not going to show those steps again. We got negative 2x squared minus 3x plus 2 over x plus 1. First thing we find is the vertical asymptotes. Vertical asymptotes, you factor the top, factor the bottom. Cancel if possible. I don't think this factors and cancels at all. So we'll set the x plus 1 equal to 0. Is that a true statement? Let me see. Negative 2x squared minus 3x plus 2. I'll factor our negative 1 out, and that gives us 2x squared plus 3x minus 2. 2x times x, 2 plus minus 1, 2x squared, 4x, 3x. Oh, it does factor. But it won't cancel with the bottom part. But you would cancel if possible before you set your denominator equal to 0. So our vertical asymptote is x equals negative 1. Now for a horizontal asymptote, if your degree at the top is larger, there is none. For the slant asymptote, you do what we just did up above, and I think we said negative 2x minus 1. Yep. Okay. Then we find our x-intercept. For your x-intercept, you plug 0 into the other variable, so plug 0 in for y. And remember, f of x is y. So we got 0 is equal to negative 2x squared minus 3x plus 2 over x plus 1. Now, assuming nothing can cancel, when you're doing this, the bottom part just drops away. And you set the numerator equal to 0. Because 3 divided by anything is 0. Unless it's 0 down here. Okay. Well, this factors. We already saw that up above. Now factor out a negative 1 first. Like that. And this factored, how did that factor? Plus, minus there. And zero factor property, you get 0 one side, you set each factor equal to 0. So I got 2x minus 1 equal to 0, and x plus 2 equal to 0. And this gives me 2x equals 1, or x is equal to 1/2. And this gives us negative 2. And then for our y-intercept, we plug 0 into the other variable. So I'll plug 0 in for the x. I got negative 2 times 0 squared minus 3 times 0 plus 2 over 0 plus 1. All those zeros drop away, and we got 2 over 1, or 2. So let's see what in the world we got here. Vertical asymptote x equals negative 1. Means we got an invisible line that's graph's going to skim at some point. Now the slant asymptote, that should be a dotted line, but oh well. Okay. And then, so we got here, an invisible line your graph's going to skim. Oops. Straight line. The graph will skim at some point. No horizontal asymptote. Our x-intercept is 1/2 and negative 2. So it's intersecting here and at 1/2. Right there. And then my y-intercept is at 2. Like that. Well, what my graph's going to look like, roughly, without plotting a bunch of points and getting an idea like that, it's going to look like this. Skimming this, and passing through this point. Now over on this side, it has to pass through this point, so it's going to somehow go through that point. And then, I guess it has to, let me try that again. Okay. Hopefully I can do this without erasing the entire thing. Okay, there we go. I probably should have spent a little bit more time and plotted a few more points. Okay, passes through there, hits that, and then comes up like that. So if we look at our graphs again, looks like B, or wait a minute, scroll down. Okay, it looks like C would be our answer, which is the same thing we found up here. So that's how you do it by hand, is you use all these different pieces, and actually you'd probably plot a few points too, just to verify and get everything a little bit more accurate than what I did. But I'm just sketching this, giving you an idea. Most of you probably do it on the calculator.